Video 82 for math lesson 10.1. Pan balance problems. Now in your math message you were asked to answer the math message question at the top of page 333. And it asked you to explain how to use a pan balance to weigh an object. Now I want you to be sure to have your explanation here and be prepared to explain it in class tomorrow. This is a picture of a pan balance, and so when we talk about pan balances, this is kind of what we're picturing. And basically in a pan balance, whatever you have on the left side balances out with whatever's on the right side, and then you know that the pans are in perfect balance. We're going to be talking a lot about pan balances because we use this idea to help us start thinking about algebra. So let's take a little bit closer look at pan balances and what are we looking at if we're doing pan balance problems and equations. Now, if two different kinds of objects are placed in the pans of a balance so that the pans balance, then you can find the weight of one kind of object in terms of the other kind of object. For example, if we put a bunch of paper clips on the left side and we put a bunch of marbles on the other side, or some marbles on the other side, and we balanced it out, then we would know how many paper clips balance out with the number of marbles that we have. And we could use that to figure out how many paper clips balance out with one marble. When you solve a pan balance problem, the pans must balance after each step. Okay, so that you have to always keep the pans balanced. If you always do the same thing to the objects in both pans, then the pans will remain balanced. For example, you can remove the same number of the same kind of object from each pan. As long as you're removing the same thing, you're still keeping those pans balanced. If the pans balanced before you removed the objects, they will remain balanced after you remove them. So that just means, like, if you can take off two paper clips from both sides, you're not going to change the balance of the pans as long as you remove the same thing from both sides. Let's take a look at what pan balance problems look like. Here's an example. How many paper clips balance one pen? And here's our picture. Okay, see, this is our little picture of our cute little pan balance. Whatever is in this tray balances out with whatever's in this tray. So over here we've got 5 pens and 10 paper clips. And on the right side we've got 2 pens and 40 paper clips. Now we can figure out how many paper clips will balance one pen with the information that we have here. For the first step, we can remove 10 paper clips from each pan, and that'll keep the pans balanced. Because I can take 10 paper clips away on the left side, I can take 10 paper clips away on the right side. So now I'm left with 5 pens over here and 2 pens and 30 paper clips on the right side. They're still perfectly balanced because we removed the exact same amount from both sides. Second step, I can remove 2 pens from each pan, and that will still keep the pans balanced, as long as I remove the same amount from each side. So if I take these 2 pens away and these 2 pens away, I'm still going to be in balance because I took off the same exact thing from both sides. Now, what I'm trying to do here in these steps is I'm trying to get it so that I have only pens on one side and only paper clips on the other side. That way I can see how they balance each other. So I'm going through these steps to try to figure that out. Now, after I take 2 pens from each side, I've got 3 pens left on the left side, 30 paper clips on the right side. Well, if I remove 2/3 of the objects from each pan, it will keep the pans balanced, okay? Because in other words, think about dividing by 3. Since I've got 3 pens and I want to know how many paper clips balance 1 pen, I could divide those by 3. I've got 30 paper clips over here. If I divide them by 3, or in other words, remove 2/3, what will be left? We're left with 1 pen and 10 paper clips. Now, these are equations, and in this first example here, we used all pictures, lots of pictures. I guess we had a little bit of numbers here so that we didn't have to draw 40 paper clips out. But we used pictures to represent things. We can also use numbers and variables to represent things in our pans as well. And in fact, that's what we'll be continuing to move toward, is using numbers and variables, because that's what algebra is all about. You can think of equations as models for pan balance problems. The example on page 228, this is in your student reference book, can be modeled by the equation 5p plus 10c equals 2p plus 40c. C stands for the weight of 1 paper clip, P stands for the weight of 1 pen. Okay, do you see where those come from? In this problem, we had 5 pens and 10 paper clips on the left side. So we could call that 5p, where P stands for pen, plus 10c. C stands for the clips, the paper clips. That's what we had on the left side. And on the right side of the balance, we had 2 pens and 40 paper clips. So we could represent that as 2p plus 40c. Okay, so it's the same exact problem. We're just using numbers and variables rather than pictures. Now we do the same steps to solve the problem. Okay, we can remove 10c from each pan. Okay, if I take 10c out here, we're left with 5p on the left and 2p plus 30c on the right. Then we can remove 2p from both sides. Okay, and now we're left with 3p on the left and 30c on the right. Now we can think of either removing 2/3 of the objects, or I personally prefer to think of it as like divide by 3. I know, remember here, 3p, 5p, it means the same as 5 times p, or 3 times p. In algebra, you don't have to write out the multiplication symbol when you're multiplying a number times a variable. They kind of write it like shorthand like this. Okay, so 3 times p is what 3p stands for. And I know that if I'm multiplying by 3, I can do the inverse operation and divide by 3 to get just 1p all by itself. Okay, if I have 3 and I want to know what 1 is, I divide by 3. So if I divide by 3 on both sides, I've got 30c. If I divide by 3, that leaves me with 10c, 1p over here. Remember, p means the same as 1p, or 1 times p. We just don't need to write that 1 times. Okay, so p stands for 1 pen. What this is it's algebra, and we're beginning to work with algebra. I want you to put some of these notes in your notebook. So go to your next clean page. Your heading is algebra, so write that down, and copy down these notes. Now, think of the equal sign as a balance. Whatever's on the left of the equal sign must always be balanced with what is on the right of the equal sign. So our pan balances are really representing equations. and the balance in the middle is like the equal sign. So the left pan is whatever's on the left side of the equal sign. The right pan is whatever's on the right side of the equal sign. What we're talking about here are equations. Okay? An equation is a number sentence that contains an equal sign. For example, 15 equals 10 plus 5. 7y equals 10 plus 11. Even 1 plus 1 equals 2 is an equation. Okay? It's just a number sentence that contains an equal sign. An expression is different than that. An expression does not have an equal sign. It is a group of mathematical symbols or numbers that represent a value. For example, 3 plus 4. We know that 3 plus 4 represents the value 7. Okay, so 3 plus 4 is an expression. 7x, that's an expression. 8 minus 4 divided by 2. Y plus k. These are all expressions. They are not equations because they do not have an equal sign with the value equal to it on the other side. Okay, make sure you have all of these notes copied down into your notebook before you finish here. And the rest of your assignment tonight asks you to try to solve the pan balance problems on page 333 and page 334. Now some of them will be very simple. Okay, they're designed to start out simpler and get a little bit more advanced as you move along. Okay, just give it your best shot. Try to see if you can figure out the solutions to the problems. And tomorrow in class we'll go over them and you'll have a chance to see how you did. And if you were able to get some of the most tricky ones, especially the try this problem on page 334. It's a pretty tricky problem and I'm really excited to see if anyone is able to figure out that solution. So good luck!